Hi everyone, welcome to NCKHUB. We are going to start a series of videos on data structures and algorithms. So today in this video we are going to cover what is a data structure and what is algorithm and what is the terminology we are going to use in this data structures and algorithms. And in this video we covered one sorting algorithm, that is bubble sort. So let's see like what is a data structure. So data structure is a way like to store our data and organize the data. So structure data in different ways on depends on the type of data we are holding and what to do with that data. So yeah, data structure like also gives us insights in managing large amounts of data efficiently for using in large databases. So data structures also help us in creating fast and powerful algorithms. So it also helps in managing and organizing data and reduce the complexity and increase the efficiency. So coming to primitive data structures like which is going to hold a single value such as integers, float and characters and boolean. So and coming to abstract data structures like we have arrays, linked list, tags, queues, graphs and trees. So here, we are going to perform different types of operation on these data structures. So we'll be covering that in the later videos. So and what is algorithm? So algorithm like is step-by-step instructions like we are going to write in order to solve a problem. So in terms of program, like we'll be writing instructions like what are the tasks it is going to perform and whatever the language we are writing, either Python, Java, C++, or C, anything. So we'll be writing those statements and then it is going to execute based on that. So efficient algorithm like it is going to helps to find the solution and transforms a slow program into faster. Like if you write it very efficiently, like we can improve the performance as well. So simple example is like sorting, like sorting the movies by name or year or rating, something like that. And in case of search, like what user really wants to search for a simple text or something like that. And navigation in terms like how to get the fastest route for our destination. And terminology like we have different terms like algorithm. So we have seen in earlier slide like it is a set of like instructions in order to solve a problem. So data structure like way of organizing the data. And time complexity like amount of the time like it is going to take to execute the algorithm. And space complexity like amount of memory it's going to use. And big O notation like limiting the behavior of function like when an argument tends to a value or infinity. And like time complexity or space complexity like will be referring with O of something. And recursion is like a function is going to call itself. And divide and conquer like when it comes to a complex problem like we are going to divide it into subtasks, and then we are going to solve those subtasks and then we'll be combinedly solving that complex problem. And basically like we are going to combine all the solutions in order to solve a complex problem. And brute force is like simple algorithm like we are going to try with all possible solution and we are going to pick the best one. Yeah, so another example is like in this video we are covering like bubble sort algorithm. So basically bubble sort algorithm is a kind of sorting algorithm which is going to rearrange the elements in a particular order, either ascending or descending. And among them like bubble sort algorithm is the simplest one. So which is going to work on adjacent elements. So when it satisfies the condition, it is going to swap the elements if they are not in the intended order. So it going to move the elements from one end to end in each iteration. So when it comes to the performance of bubble sort, it is very poor and it is not suitable when there are large data sets. And average and the worst complexity is order of n square. So basically n is the number of elements that are present in array or list. So yeah, basically we'll be using bubble sort in an scenarios like complexity doesn't matter, and it is like program is simple and short. Yeah, so bubble sort algorithm. So this is the simple one. We are going to start the function like by taking input as array, and then we are going to start a for loop, and like that is an iteration it starts, and it is going to compare the two adjacent elements. So if it satisfies the condition, we are going to swap the elements, and if not, if the swapping is not required, so just move to the next adjacent two elements. So that's how we are going to iterate the loop. Yeah, so yeah, this is a simple example. We are trying to understand the bubble sort algorithm. So for this example, I took like five elements: 18, 34, 28, 39, and 9. So these are my array elements. So in the first iteration, like sorting algorithm is going to start from first two elements. So basically it is 18 and 34. So it's already in. So I want to sort the elements in ascending order. So my smallest element will be the first, and largest number will be the last. So 18 and 34, 18 is already smaller one, so no need to swap. And then it is going to move to next adjacent two elements like 34 and 28. So here 34 is greater than 28. So here swap is required. And then after swapping, my element array is going to become 18, 28, 34, 39, and 9. And then I'm going to compare the next two elements 34 and 39. So yeah, here it's already in sorted order, and no swapping is required. So coming to the last, so 39 and 9. So here 39 is greater than 9, so swapping is required. So after swapping, elements are 18, 28, 34, 9, and the 39. So in the second iteration, 18, 34, 28, 9, 39. So here I am going to compare 34 and 28. So here again it is going to swap the elements. So after that 18, 28, 34, 9 and 39. And then again I am going to sort the 34 and 9. So here swap is required. After swap 18, 28, 9, 34, 39. So 34 and 39. So it's already inserted. So no need to swap. And in third iteration, like same procedure, like it is going to compare first two elements. Yeah, 18 and 28. So no sorting is required. And then 28 and 9. So 28 is greater than 9. So swap is required. And then after swap, you can see the elements. And then finally 34 and 39. So no swap is required. Now it comes to fourth iteration. So same process, like it is going to continue for fourth iteration. So here I am going to compare 18 and 9. So here 18 is greater than 9. So swap is required. And after swap 9 and 18. So that's how it is going to compare 18, 28. So sorry. So, so no swap is required. So next 28, 34 no swap is required, and 34, 39 no swap is required. So that's how my elements are sorted in ascending order: 9, 18, 28, 34, 39. So here if we take the complexity, time complexity, so in the best case, like when there is no sorting is required, so this is the order of n. So if my element array size is 5, then mostly it is going to take only 5 iterations. So that is the best case. And in average case, like where the elements, given elements are in jumbled order, so that is not ascending or descending. So that means my time complexity is order of n square. And worst case also, like it is order of n square, like all the elements I need to be in reverse order, so that is in ascending order, but all the elements are given in descending order. So that means I need to swap the last element to first element. So that is the worst case. And coming to space complexity, so for swapping I need one extra variable. So for that reason I am using one extra variable, I am creating it. So that's the reason it is order of 1. Yeah, so yeah, this is how simple things, bubble sort algorithm. In the next video, like we'll be covering other sorting algorithms. So now we'll see how we implement in the Java this bubble sort program. Yeah, so in this example, like I created one simple class like bubble sort demo class, and here I'm creating one array, integer array, like integer array list A with numbers 15, 65, 31, 52, 40. And then I created one object, and here I created two methods. One is like print, and another is like sorting method. So in print, I'm just printing the elements of my array. So here I got the size of integer array, and then I am iterating with for loop, and then just printing of those index based on index. So list of a of I. So that's how all the elements will get printed. So when it comes to sorting method, so yeah, after printing elements before sorting, and I'm calling this bubble sort. So here I'm getting the length of the array, and then I'm creating three variables, I, j, and the temp. So this is my outer for loop, starting with I equal to 0, I less than n, I plus plus. So I'm going to iterate with from, since it is having 6, so I'm going to iterate with 6 times. And my inner loop, so to compare with the adjacent element, so I'm going to create another for loop, inner loop, so which is going to start with j equal to I plus 1. So since I is the first, I equal to 0, that is the first index of array 15, and then I want to compare with 65. So that's the reason j equal to I plus 1. So 0 plus 1, 1. So here list a of j, it is going to be by 65, and list a of I it is 0, so that is 15. If 65 is greater than 15, so in that case, like I am, since it's satisfying the condition, I'll go inside this if. I'm using this temp variable to store the list a of I 65, and then a of j I'm going to make it 15, and then uh, first element I'm going to make it 65. So basically I'm going to swap these two numbers, 65 here and 15 as second element. So that's how first we'll be doing 15 and 65, so these two will get swapped, and then I'll move to 15 and 31. Yeah, again 15 and 31, like it is going to get swapped. So here second element I'll get 31, and then here I'll be getting 15. So again it is going to get 15 and 52. So again I'm going to swap these two. So 52 here and 15 here. So again 15 and 40. So again these two will get swapped. 40 here and 15 here. So again 15 and 20. So again these two will get swapped. So here 20 will come, here 15. So my first element is moved to last. So that's how it is going to do it in the first iteration, and then it is going to come the next here to the second point 65, and then j equal to I plus 1. So it is going to do the comparison here. So already 65 went here, and then 31 comes here. So 65 and 31, so this already less. So sorry, 31 and 52. So again these two will get compared, and elements will get swapped. So that's how elements will get swapped. So now if I execute this, so here my elements are sorted in descending order. Okay, 15, 65, 31, 52, 40 and 20. So after sorting, so 65 comes in the first, and 15 in the last, and then second it is 52, 40. Suppose I want to sort the elements based on ascending order, then I need to change this as less than, and then the elements will be sorted in ascending order. Yeah, here we can see first element is 15 after bubble sorting, so second 20, and third one is 31, fourth is 40, fifth is 52, and last one is 65. So yeah, that's how we'll implement the bubble sorting algorithm. uh, Thank you so much.